Hi guys. In this video, we are from here onwards. We are started a new series on one of the most important topic. Currently and in the future also, it's going to be more important to this world, and that's quantum physics. I recently planned to study about the quantum computing and before that it's better to know about the quantum physics. If you understand the core basics of the quantum physics, it's easy in the quantum computing. In that way, I went a lot of learning process, and I went to many blogs, I went to many videos to where to start, where to learn all the things. Then I made some process, and according to that, I plan to make a series which is helpful to these people who are planning to study in the quantum physics. Let's go into this. I made few slides which are required to just grab my things from my brain, and with this way I can give more insights about the things. And this is just introduction video. In this video we are going to not going to discuss any technical stuff. We'll discuss what are things and what are stuff we are going to be discuss in the future, all the things. It's like a index to this entire series. Okay, let's go to the slide. Introduction to the quantum physics. Let's ask a question like, oh, what is quantum physics? Let's go with what is quantum. So, if you look at the quantum word, it's very macro level. You need to think about very macro, and if it's very macro, we can't see. Then you should visualize the things. That's the most important thing. The quantum physics, everything need to be visualized. If you have good visualizer in the mind, you are the rock star in this physics. And yeah, I think many people are know about the classical physics because of Einstein or Newton, or else we are studied in the college days. Because of all the things we know mostly about the quantum physics, but we also study the quantum physics also, but we don't know differentiate that classical physics with quantum physics. Are studied, we was studied, sorry. And uh, yeah, why we require the quantum physics? That's first question we need to get. uh, so in the classical physics we are discussed, we were mostly about the macro level. It's like planetarium, just earth, so all solar system, universe, all the things we discussed about the uh, how the object is moving. But when we enter into the micro level, like quantum level, these things are bit different, going different compared to the classical physics. For that, we separated a, a category of physics is a quantum physics, which is become more interesting and more spreaded, and this is going to be rule the world. Yeah, and let's say there's also some applications also is there, like the quantum chemistry, and over there we are so currently going a lot of research on this quantum. Mostly in this quantum chemistry we are folks are developing new drugs, and which is more effective and less side effects, those kind of drugs developing. And this is quantum field theory. This quantum technology, more emerging technology, that's a quantum computing. Yeah, that's a quantum signal processing, all that stuff will come in the quantum technology, and it's rapidly going on of the technology. And then quantum information science, information science, we are storing some information. Like here will come like encryption, decryption, those kind of stuff. Uh, yeah, this is a place where the most of the things have started, I think. And yeah, oh, okay, let's see how they're different from the classical physics to the quantum physics. In this slide, we are going to be explain those things. First thing is quantization. We have the energies are continuous and the other is continuous, but on the quantum level we have the continuous and the discrete values also. They call quantization, as we call. And the most important thing is wave particle duality. This is one of the main reason to come this quantum physics, because in the classical physics we are the object behaves like either wave or either particle. Just only one of property will be there. According to that, we are applying the physics, maths. Okay, physics and maths are same, not as different. Most of the things. Yeah. So this bullshit thing, wave particle duality came, and this objects are behaving like a particle as well as a wave. Then this started, and then uncertainty principle. Okay, so one of the uh, most important things, uncertain principle. It is telling like we cannot find the position and the momentum at same time at any instant. When I was in the college days, one of my professor discussed this about, but I don't know that time. It's a quantum physics thing. Uh, he said as a car is moving, is given some example related to uncertain principle that he mentioned. If his car is moving, how we can find the position of and movement at same time? We cannot find. He's given with that example very beautifully, and I strike that time, but I don't know at the time it's a quantum physics. I thought it's a physics. Even at the time I don't know the quantum physics system actually. Yeah. This is the topics we are going to discuss in the entire series. uh, so initially we'll go with some facts. If there should be some facts to be start this physics, quantum physics, we'll discuss those facts, like how the people got to know these micro things, like atom and this electrons, protons. Oh my god. We'll discuss those all the things. And also photoelectric effect and electron diffraction is one more thing we will discuss. Okay, and the Bell-Poor equation. Bell-Poor, yeah. Also one more equation which is a very good equation which many times we will use in the classical physics, which is not applicable in the quantum physics. Why it is not applicable also we'll discuss. Mostly these facts of life will cover in the first video only. And the wave function, we told this object is work like a particle and a wave. Then it should follow some properties because it's exhibiting both properties. Then we will discuss what are the properties. We're not going to discuss all the properties. We will discuss all important properties which are required, which I learn and what I feel important. I will discuss those properties. Then after this operators, without operators, anything is gonna be difficult task. If you wanna do any, like if you take just any mathematical, like without any operations, visualizing the math is very hard. Okay, but this quantum physics is a bit different from the classical physics. We require different kind of operators. We will discuss operators like momentum operators and the energy operators, and also one more commutator is very important. We'll derive that also, we'll discuss about that also in brief, and we'll touch that commutator many videos, and not only one. And then main rock stories here is Schrodinger equation. We'll discuss and we will derive also Schrodinger equation, and then we'll go into the applications of Schrodinger equation. One of the greatest and the easiest application is quantum harmonic oscillator, and we'll discuss applications like in the infinite well, how it's working, and then after we'll go with the finite well with different levels of energy. uh, we'll discuss all the stuff over there. Then after we'll go with angular moment. Until now we'll go only just 1D. Then after we'll go into the higher dimensional space, and we'll discuss about the angular momentum, and then scattering. This angular means very nice concepts, and recently many places this concepts using. We'll discuss that very effectively. It's a bit confusing, but I'm here to explain. No worries. And the scattering also will discuss. These are the this broad idea about this series. Yeah, this is just all about this video. We'll